The problem is from GATE 2022 mathematics paper, question number 56. The problem is consider R cube as a vector space with the usual operations of vector addition and scalar multiplication. Let x belongs to R cube be denoted by x equal to the ordered 3 tuple x1, x2, x3. Then define subspaces w1 and w2 by w1 is equal to the set of all vectors x in R cube such that x1 plus 2x2 minus x3 equal to 0 and w2 equal to the subspace set of all vectors in R cube x such that 2x1 plus 3x3 equal to 0. Let dimu, which denotes the dimension of the subspace u. Then which of the following statements are true? The four options given are: option A, dimension of w1 equal to dimension of w2. Option B, dimension of w1 plus dimension of w2 minus dimension of R cube equal to 1. Option C, dimension of w1 plus w2 equal to 2. Option D, dimension of w1 intersection w2 equal to 1. The NPTEL reference to solve this problem are the linear algebra by Professor K.C. Sivakumar video. He is from Department of Mathematics, IIT Madras. The video is lecture 12 from module 3. The title of the lecture is Dimension of a Vector Space. The YouTube link to watch this video is as this. Now coming to the useful data from the given problem is, in the given problem the vector space given is R cube and the vectors in R cube are taken as x equal to the order 3 tuple x1, x2, x3, and we know that dimension of R cube is 3, as we have the standard basis for R cube over R as 1 0 0 0 1 0 0 0 1, and the subspaces in the problem given are w1 and w2, which are w1 equal to x belongs to R cube such that x1 plus 2 x2 minus x3 equal to 0, and w2 equal to x belongs to R cube such that 2x1 plus 3x3 equal to 0. These two are the subspaces. If we look at the options given, we can see that all the four options are asking about the dimensions of the subspaces. This about the subspaces w1, w2, w1 intersection w2 and w1 plus w2. So what we have to do is we just have to calculate the values of dimension w1, dimension of w2, dimension of w1 intersection w2. Then we can calculate the value of dimension of w1 plus w2 by a formula. So firstly we start with dimension of w1. So for this, firstly we let a vector namely x as x1 comma x2 comma x3 in w1. So then by the given condition we have x1 plus 2x2 minus x3 equal to 0. From this we can see x3 is equal to x1 plus 2x2. By just rewriting x3 in the given vector, we get x equal to x1 comma x2 comma x3, that is equal to x1 as it is, x2 as it is, and we got the value of x3 in terms of x1 and x2 as x1 plus 2x2. So now this vector can be rewritten as linear combination of two linearly independent vectors such as x1 times 1 comma 0 comma 1 plus x2 times 0 comma 1 comma, and we can see that these two vectors are linearly independent. That means any vector in w1 can be written as linear combination of two linearly independent vectors. So we can see dimension of, sorry, we can see W1 is the subspace generated by the two vectors as 1 0 1 and 0 1 2. So from this we can see, and these two vectors are linearly independent. That we can check easily. So we can say dimension of W1 is equal to 2. And now for dimension of W2, we again let an element, a vector, we let a vector x as the order tuple x1, order 3 tuple x2, x3 in W2. Then by the given condition for W2, we have 2x1 plus 3x3 equal to 0. From this we can see x1 in terms of x3 as minus 3 x3 divided by 2. By just rewriting the value of x1 in terms of x3 in the given vector x equal to x1 comma x2 comma x3, which can be rewritten as x1 in terms of x3, that is minus 3x3 divided by 2, x2 as it is, and x3, and which this vector can be written as the linear combination of the two vectors as x2 times 0 comma 1 comma 0 plus x3 times minus 3 divided by 2 comma 0 comma 1, which is in the subspace W2. That means any vector x in x in W2, we can see x can be written as linear combination of these two vectors, and we can observe here that the two vectors, these two vectors are linearly independent. So we can say W2 is the subspace generated by the vectors 0 1 0 and minus 3 divided by 2 comma 0 comma 1 and 0 comma 1 comma 0 minus 3 divided by 2 comma 0 comma 1 are linearly independent. So we can say dimension of W2 is equal to 2. So by looking at the options, we can say the first option is correct as we get dimension of W1 equal to dimension of W2 equal to 2. And coming to the second option, we have that dimension of R cube as 1. So dimension of W1 plus dimension of W2 minus dimension of R cube is nothing but 2 plus 2 minus 3, which is equal to 1. So option from the option B, we can say this is correct. Now coming to the option C, we have to calculate the value of dimension of W1 plus W2, for which we have a formula in terms of dimension of W1 intersection W2. So firstly, we calculate the value of dimension of W1 intersection W2, then we can look into the option C. So for dimension of W1 intersection W2, similarly, we first let a vector x given as x1 comma x2 comma x3 in W1 intersection W2. Then by the given conditions of W1 and W2, we have x1 plus 2x2 minus x3 equal to 0 and 2x1 plus 3x3 equal to 0. Let me name these two equations as 1 and 2. Then from the equation 1 implies we have the value of x3 as x1 plus 2x2. Whereas the equation 2 is dependent on x1 and x3. So substituting the value of x3, which we got from the equation 1 into, we get the equation 2 implies 2x1 plus 3x1 plus 6x2 equal to 0. So we have the value of x2 as minus 6 x1 divided by 5. So we can see the value of, so by substituting the value of x2 in this equation, we get the value of x3 in terms of x1 only. That is, now x3 equal to x1 plus 2x2. The value of x2 we have as minus 6x1 divided by 5. So I can write this as minus 12. Sorry, we have the value of x1 as minus 6 x2 divided by 5, and the value of x3 equal to value of x3 equal to x1 plus 2x2. That means minus 6 x2 divided by 5 plus 2x2. That is nothing but 4x2 divided by 5. So we can see the value of x1 in terms of x2 and the value of x3 also in terms of x2. So we can write the vector x as, so x given as x1 comma x2 comma x3 can be written as the value of x1 is minus 6x2 divided by 5, and the value of x2 as it is. Then the value of x3 is 4x2 divided by 5. 4x2 divided by 5, right? So we can write this vector as x2 times minus 6 divided by 5 comma 1 comma 4 divided by 5, which is in w1 intersection w2. That means for any vector x in the subspace, w1 intersection w2 should be generated by the vector minus 6 divided by 5, 1 comma 4 by 5. So we can say w1 intersection w2 is the subspace generated by the vector minus 6 divided by 5, comma 1 comma 4 by 5. So dimension of, therefore dimension of w1 intersection w2 equal to 1, which is nothing but the option 4. So option 4 is correct. Now coming to the option 3, it is asking about dimension of w1 plus w2. So we have a formula that dimension of w1 plus w2, we have dimension of w1 plus w2 is equal to dimension of w1 plus dimension of w2 minus dimension of w1 intersection w2. Since we have derived all the values of dimension of w1, dimension of w2 and dimension of w1 intersection w2, by just substituting we get this value as 3, and but the option given is the value of this is 2, so which is the wrong option. So the correct options are A, B and D. Thank you.